Okay, dear students, let us see another example um, for mathematical induction. So this is another type that we have now. This is 8A question that we are going to do. So what does this mean first of all? Like summation of I, where I, the counter starts with 1 and it goes to n. What does it mean? It means that we substitute 1 here first of all, and then we have addition, because this is summation, the symbol of summation, and then we go for 2, then we go for 3, and then likewise we go up to n. So this is how we can expand the summation term. Okay, so this is how we do it, and this thing is equal to n into n plus 1 divided by 2. So this is our proposal, that this is equal to n into n plus 1 by 2, and we have to prove it by the mathematical induction. So first of all, step number 1. So we are substituting n is equal to 1. So obviously this summation will come out to be equal to 1 only, because there is going to be only one term. So the summation will come out to be equal to 1, and let us substitute 1 here. So it will be 1 plus 1 divided by 2, and yes, it is also coming out to be equal to 1. So this statement is absolutely correct for n is equal to 1. Let us now take an assumption that it is true for n is equal to k. So be very careful now what I do here. There's a big trick coming our way now. So instead of n, I'm writing k, which is k into k plus 1 divided by 2. So what is now going to happen here? K plus 1 means that we are going to take one more term here. We are anyways going to take up to k, but we are taking one more term, that is k plus 1. It is the next term that is here, and we need to prove it, that this is coming out to be equal to, I substituted k plus 1 here. Yes. So this is our proposal. This is the assumption that we have taken, and if this is true, the step number 3 should come out to be equal to, it will come out to be true. So how can we do that? So this is the statement in front of you on your screen. So this complete term is now substituted here, and it will be substituted like k into k plus 1 divided by 2 plus this term comes here now. K plus 1 is equal to k plus 1 into k plus 2 divided by 2. This is what we need to prove. So this is up to this is the principle of mathematical induction. Later on, it just reduces itself to simple mathematics. Now we are going to use algebraic principles to prove it. K plus 1, k plus 1 and k plus 1 will get cancelled out. So we have k plus 2 plus 1 here, and k plus 2 divided by 2 here. Now we can take LCM on the left hand side. It is coming out to be k plus 2 divided by 2 is equal to k plus 2 divided by 2 on the right hand side. So LHS is equal to RHS, and hence by the principle of mathematical induction we can say that the polynomial n plus 1, the statement is correct for n plus 1 if the statement is correct for n. And because we have proved that it is correct for 1, it is correct for 2, correct for 3, correct for 4, and likewise it is correct for all the integers. So this is how we do this question. So there is a great deal of confusion students have when it comes to series, like what is this summation, how to write it. We would be taking one more example from a similar type, and then we will move further. So till then, all the best. Bye.